Good morning. Thank you all for coming out at this unreasonably early hour. And my name is Christophe Pettus, and we're going to talk about administering PostgreSQL when it's not your job. So the reality today is we find ourselves in this DevOps world, and you can go out on Google and find like all sorts of different definitions of DevOps, like integration between development and operations, or it means cross-functional skill sharing, or it means maximum automation of deployment and development and deployment processes. And what it really means is we're too cheap to hire operations staff. Anyway, cloud solves all problems, right? You just say we're cloud-based and then you don't have to hire anybody. So what this means in reality is in today's world, we have echo there, good. You have no experienced DBA on staff, and you see how much those people cost to hire, so you don't want them. And which means development staff are pressed into duty as database administrators. I would say that in probably 90% of startups that I consult with, this is the situation. There's no one whose job it is to keep the database happy. It's the developers who are like, well, install something already. But that's okay, it's Postgres. But you specify Postgres and then use here, but it's hard to configure, or it requires a lot of ongoing maintenance, or you have to throw really good hardware at Postgres to get good performance. And anyway, it's SQL, which is boring, and also it's not web scale. TM. Or elephants scare me. So, and then you pop open PostgreSQL.conf and you look at it, it kind of looks like this. And your reaction is that, because it has like 385 configuration parameters, some of which have comments that seem to be written in Armenian as to what they actually do. But we are here to tell you it's really like this. You can like edit 3 things, close it, never look at it again, and life is good. So what we're going to talk about is how to configure and maintain Postgres with minimum effort and fuss. Just as by way of observation, I bought this machine back off of the Dell website in 1997, and it's currently running 9.2. It's sitting there in my server closet. Pat it on the head. Pat, pat. So if this machine can run 9.2, anything can run 9.2. And I spend about an hour a year maintaining this box. Eventually the hard drives are going to die, but it's doing pretty well so far. SATA drives, or SAS drives, buy SAS drives. So let's talk about PostgreSQL when it's not your job. We're going to talk about basic configuration, easy performance boosts, and avoiding a few very common pitfalls. How to do ongoing maintenance in a way that will not drive you crazy. And we're not going to talk about hardware selection. Part of it is just there's only so much time we have on the talk. And also, these days, pretty much everybody is kind of like firing up these cloud servers and shoving Postgres onto it. So the hardware selection is the least of your worries. Or if it's the most of your worries, there's not much you can do about it. But I'll be glad to take questions about hardware stuff at the end. So hi, I'm me. I've been doing Postgres since 1997. I actually come from an application development background. I got involved in Postgres because I was at Oracle, doing Oracle stuff at the time, and I was getting sick of how much we were having to spend for Oracle, on Oracle licenses. So I started shopping around and ran across Postgres and went to my boss and said, you know, this is ridiculous. We can install all these instances of Postgres, 7.1 I think it was at the time, for nothing, and we won't have to write these Oracle licenses. And in my next job, I started using Postgres. So let's see, I've been doing Django since 2008. I'm kind of the app dev guy at where I work, which is PostgreSQL Experts. We're a San Francisco-based Postgres consultancy. And the slides will be available there. That's my website, thebuild.com. Or you can follow me on Twitter. OK, so a little bit of philosophy before we plunge into the technical details. You really can't break PostgreSQL unless you really want to. There are very few ways to actually smash up Postgres in the standard configuration. If you avoid a few basic problems, you'll be fine. So don't agonize over PostgreSQL.com for something. Most of the time when you run into problems with the database, it's because your application isn't using it right. Postgres itself has been around for a couple of decades now. It kind of knows what it's doing about managing data. It's a lot of times I will go into a client and they'll say, oh well, we're doing 500,000 inserts. of all this data. We have this giant trigger that's running on every insert. It's really slow. Why does Postgres suck? It's like, well, I've got some bad news for you. But anyway, just don't obsess about tuning. This is not where you need to spend your time. So there's a lot of material in this talk, so there's no time to explain. Just do this. Trust me. After years of experience, this is the right way to set up a Postgres server. I'll take questions as for a justification if you'd like later. Okay, so how do you install Postgres? Just use the packages. Interestingly enough, I used to be a compile it from source kind of guy, in part because the distro packages, that is to say the ones that the Ubuntu project or the Debian project or CentOS or Fedora come out with, tend to be kind of old. They don't tend to stay up currently. So my philosophy was I'll build everything from source. I'll use, I love Configure, I love AutoConf. It's just the greatest thing ever. That has changed now. You can find very up-to-date, like 12 hours after a release, the packages are available, kind of packages now, for all the major Linux distributions at least. Enterprise DB does a very good job of keeping the Windows versions up to date. So just use packages. It solves a raft of weird installation problems. One example is Martin Pitt maintains a set of a repo for Ubuntu, which is very popular as a server OS now. So just get the stuff from him. Just use apt-get or yum or whatever, aptitude or yum or whatever your local package manager is. It's really easy. It'll even fire it up for you when you are done with apt-get Postgres. The server's up and running. So that's really easy. A little bit about configuring Linux in particular. I'm not a Windows guy, so I can't really give much advice on that in that regard. But for Linux, first thing, turn off the ohm killer. The ohm killer is a bug, not a feature, especially on a server. If there are any Linux kernel developers in the audience, which I doubt, I apologize for this comment, but it's true. We're right, you're wrong. When you're setting up your file system, use ext4 or XFS. By default, most things will initialize as ext3. That is wrong for a database operating system. Which one you use is entirely a matter of taste. Most distros have kind of like its favorite of between the two. Use that one. XFS has been around a little bit longer than ext4, but that's so who cares? Use one or the other. Don't use ext3. It's not ideal for a server file system. And someday we will be rid of this. Actually, someday maybe 9.3. But for now, there are two kernel parameters you have to set: shared memory maximum and shared memory all, known by their so euphonious names of schmax and schmall. Sounds like something cartoon characters would say on Saturday morning. Gotta set those schmacks. And because otherwise Postgres will write this very informative but very unfriendly message out which sort of characterizes the Postgres mailing list, informative but unfriendly, when you try and start the system. And there's actually very good documentation in the Postgres docs on how to set those. Okay, so now you configure your operating system. Well, that was easy. So let's talk about Postgres configuration. Everybody should know there's a one big file, postgresql.conf, which controls pretty much all of the interesting settings. There's also one we're not going to talk about, which is pg_hba.conf, which controls security for Postgres. But all the action happens in postgresql.conf. It's a text file, lives at the top level of the Postgres database. We're going to talk about how to set logging, resources, checkpoints, the planner, and that's it. So there are 4 areas of settings you need to change. And in each, you need to change about 2 or 3 settings apiece. So we're talking like 12, 16 settings, you're done. Really, you're done. So logging. PostgreSQL has lots of things that are called logs. And that's kind of a shame because there are some that are like boring text logs that just say, I did this query, this error occurred, that kind of thing. And there are other things that are called logs, like transaction logs, that are really important and you shouldn't touch. So the ones we're going to talk about are the text logs. They're also called the error logs, or sometimes the standard error logs. There isn't a single good term for them, which is unfortunate. The documentation kind of needs to clean that up. These are the logs of Postgres operations. They're text files. They can be sent to a variety of, they can be written to files or they can be sent to syslog. we do this first because some of the other things that you set are based on information that you gather out of these. So do logging first. Be generous with it. Turn it up. It's very low impact on the system. You want that information. And also, for finding performance problems, the logs are the first place you go. So logging is your friend. Be generous with it. So your first decision is, well, where do we put these things? So they're big old text files. If you already have syslog, if you're already using syslog in your system administration world and you like it and you have an infrastructure set up, just use syslog. It's there. Integrates in with everything else. Most people don't. Syslog is kind of something that happens to other people for most new installations. So in that case, you can write standard format, which is the traditional old school format for logs. It's intended to be kind of human readable. If you have tools that you know about that use it, it's a good format to have. The more modern format, and the one we recommend if you don't have a reason to use another one, is called CSV format, comma separated values. The reason is there's a lot more tools that can process CSV log files. And really, they're kind of equivalent in terms of how human readable they are. Okay, so you pick one of those based on your system. And then you decide what to log. So download the slides and just do this. Just cut and paste this stuff. I'll run really quickly what you're doing is you're turning on CSV logging, you're telling it, put it in the PG log directory. You're turning on the logging collector, which basically rotates the files for you. You're saying the file name should look kind of like this. Rotate the files every day unless it gets to be 1 gigabyte, which usually means something weird is going on in your system, and then rotate it then. If a statement takes more than 250 milliseconds to execute, log it. Log every time Postgres starts a checkpoint. We'll talk about checkpoints later. Every time a connection or disconnection happens, log those. Anytime you have a lock wait, that is to say it waits more than a second by default for a lock, log that. And tell me anytime it has to create a temporary file. Yes?
Are those the defaults?
No. Basically, very few of these are the defaults. That's why it's just cut and paste this into the bottom of your PostgreSQL.conf. This will be voluminous but not overwhelming in terms of the amount of data you get. And you really want to know this stuff, like lock waits and temp files, because those can have a huge impact on performance. OK, logging is set up. Now you then you do basic resource configuration. The first thing you said is this parameter shared buffers. People agonize over shared buffers. It's like, oh, I'll get an email from a client that says, well, we have shared buffers set to 7 gigabytes. We're thinking about bumping up to 8. Will that make a huge performance difference? And the answer is no, don't be ridiculous. You won't see anything from a change that small. Yes? Uh-huh. If you want to, you can set the min statement duration to 0, and that will log everything.
No, I don't think there is a parameter that you actually tell it to log everything or not.
Oh, that'll log all the DML, the inserts and the queries and things like that. There's a different parameter whose name I'm blanking out on right now that you can log the DDL and stuff like that.
That one.
Yeah.
DDLs and all. I think you can set DDL or log all.
Right.
That parameter. So what's your opinion about?
I'm generally in favor of it. I don't think it's not, it's a little beyond the scope of this talk, but I would be in favor of it. During production, most sites don't do a lot of DDL, but if you want to log it, by all means do so. So here's what you do for shared buffers. You don't agonize over it. You set it to 25% of the system memory up to and cap it at 8 gigabytes, and then you're done. So if you have more than 32 gigabytes in your machine, you leave it at 8. That's it. If you get this to 20% or 30%, you will never notice any performance difference in your system. So don't agonize. Just do this, and then you're done. This is based on, by the way, that Postgres is the only significant service running on this machine. You're not running your JBoss server on it. You're not running your web server on it. You're not running your Solr server on it, because those are dumb things to do, so don't do those things. Just set it to this. Yes?
At what point will you notice any kind of
if you're off by if you're off by half an order of magnitude.
So over 37.5% or over 50%?
things that don't make any difference don't make any difference. If you're off by more than 50%, you'll probably you might experience a difference depending on your workload. In a read-intensive workload, you'll experience a difference. In a write-intensive workload, you probably won't. You probably set this to almost anything you want, and you won't notice a difference. For work mem, times 4 divided by max connections. Max connections is 200 by default. You will, and you probably will end up tweaking this a little bit, but set it here to start. It's a nice conservative value. You're not going to run anything out of memory. It'll be fine. Maintenance work mem, amount of RAM divided by 16. So if you have a 32 gigabyte system, set it to 2 gigabytes. Effective cache size, RAM divided by 2. So again, if you have a 32 gigabyte machine, set it to 16. Note that this is not an allocation. This is a hint to the planner. So you're not actually going to grab 16 megabytes for something. You do grab this much memory at system start time for shared buffers. And this is these guys are allocated on demand. So again, if you're off by a bunch there, the worst that's going to happen is it may pick a suboptimal plan once in a while. Don't go over 400 initially for max connections. We'll talk about what happens if you feel a need to bump max connections up to a very high number. Okay, and then you're done. So let's talk a little bit about checkpoints before we explain how to tune them. Postgres, once in a while, feels compelled to flush all of its buffers to disk. When it does so, that's called a checkpoint. That's when the disk really starts working on Postgres. That's the highest I/O point that you'll ever see on Postgres. You can swamp the I/O subsystem that way. So it is important to tune it so that you don't swamp it. If you're running a system that once in a while just seems to like freeze and it's thrashing on I/O, it's probably a checkpoint related problem. So here's how you fix that. Checkpoints are done one of two times. It's done when the first of these two operations occur. A particular number of wall segments, and for purposes of this discussion, we're not going to go into details. It's a certain amount of change has happened to the database. You've written a certain amount to the database. Or a timeout occurs, and the timeout is really straightforward. It's just a wall clock time. When the first one of these happens, Postgres starts a checkpoint operation. So this is where you start. You set wall buffers to 16 megabytes. Don't worry about that value. That's just the right value. It's not the default for some reason, but it is just the right value. Set the checkpoint completion target to 0.9. Set checkpoint timeout to between 10 minutes and 30 minutes, and checkpoint segments to 32. Just set these values. Where to set checkpoint timeout depends on how much the higher values will be better performance in general. Will generally demand less I/O off the system. But Postgres will take longer to restart in the case of a dirty failure. If you just shut down the system cleanly and bring it back up again, Postgres starts immediately no matter what that value is set to. But in the case where Postgres crashes and needs to recover, the higher values will result in a longer startup. A rule of thumb is it'll take about 20% of that value to start up at the maximum. It can take a little bit longer in 3 sigma cases, but so you're talking between 2 and 6 minutes. So set it kind of where your stomach is for how long you'd like Postgres to start. But again, this is only in the case of a dirty restart. In the case of a clean restart, it comes up immediately, within a minute, no matter what. So just set these values. Okay, then remember how we talked about logging. Well, you're going to go in once in a while and look at the logs. Because now it'll write a record every time a checkpoint starts and stops. So if they're happening more often than your checkpoint timeout value, keep bumping up checkpoint segments. And even once you've done that, you're still swamping the I/O subsystem, you're too busy for your hardware. This is generally where Postgres servers first indicate a scream of pain that they're being overloaded, is that the I/O subsystem can't keep up with checkpoints even after they've been tuned like this. But just to be clear, this is a pretty write-intensive workload. Most read-intensive workloads, you'll never notice this. Okay, and now you tune checkpoints. Yeah?
How much did you start
I usually do times 2. So I do 32, 64, 128. Again, this is not something you have to cut, measure with a micrometer. You just give it a lot. Say, okay, that didn't work. Because ultimately what you want is the timeout to fire, not the checkpoint segment's value to fire. Planner settings. There's this one called effective I/O concurrency. It's basically how many read operations can be going on at the same time in the system. You set the number of I/O channels. If you're running on a RAID, like a RAID 10, you set the number of disks. If you're running on an SSD, you set it to the number of I/O channels in the SSD controller. If you're running on a cloud server, set it to 1 because God only knows how many I/O channels you really have. And this helps it pick a good plan for certain read-intensive operations. Random page cost. So here's what you do. By default, it's 4. That's usually too high for most modern systems. You set it to 3.0 for a typical RAID 10 kind of thing. If you're running on SAN, set it to about 2. And if you're running on EBS, how many people are running Postgres on Amazon? Just out of curiosity, anybody? Okay. That's the low end of the curve, usually. Set it to 1.1. Because EBS is so heavily virtualized, God only knows what's going on the underlying server. Are these absolutely the perfect operations? No, but they're values, but they're going to get you very close. And you're done with planner settings. That's it. Okay, so at this point, your system is configured. So now we're going to do some easy performance boosts. Any last questions on configuration that can't be saved to the end before I move on? Yes?
Other database systems like semaphores boosted? Does Postgres care?
No. There's one thing that there is a maximum number of locks per transaction value. So if you are doing an unusually huge number of non-row locks, like locking tables and things like that, inside a single transaction, you may have to boost that. But you'll find out when it gives you an unpleasant error message because you ran out of lock table space. Very few environments need to do that. So let's talk. Oh, yes, and tuning vacuum. Everybody's favorite topic on Postgres is vacuum. General system stuff. Remember how I said don't run anything on the box? Don't run anything else on the box. There's little stuff. Obviously, you're monitoring daemon, your copy of postfix so you get alerts emailed to you. That stuff's fine. But this is the single biggest performance boost you can give. This is the first stop smoking health advice. Is that just don't run anything else on the same machine. And remember, if you're on a VM, this includes other things on this who are tenanted on the same VM. This is one of the downsides about cloud hosting. So remember, you only get one box no matter how many VMs are created on it. So the following are don't do these. Don't put sessions in the database. This is an extremely common pathology in a lot of web frameworks because it'll frequently do this by default. Django is one example of an offender in this regard. Generally put sessions in something else. Redis is a good choice. Memcached is a good choice. Those are all excellent choices. But they tend to be very high write intensive. They tend to be value that does not need to persist across system restarts. So don't put them there. A very common pathology are constantly updated accumulator records, things that like count number of sales and things like that. Generally, only collect that data when you need it. Don't create a single record that every single request or something has to pound on. That's very expensive to the system. Task queues in the database. Again, being a Python Django guy, Celery is an excellent example of this. There are queuing mechanisms that are specifically designed to handle this kind of stuff. Unless you absolutely need the database property, full database properties, use something like Redis to store task queues. Celery, in particular, polls the database. And if you have 400 workers, each one polling the database every 10 milliseconds, that could be rather a lot of traffic to accomplish exactly nothing. Using the database as a file system, very common thing. If you have giant blobs and things like that, Postgres does a much better job than most databases about handling this kind of stuff. But every modern operating system ships with a database that was optimized specifically for storing and retrieving large objects. It's called the file system. Use that. Don't use the database. Well, the usual method to do this is put pointers to the database, pointers to the files in the database, and put the blob someplace else. There are exceptions to this rule. You know, everyone can come up with every clever person come up with a reason that their blob has to be in the database, but those are edge cases, not the common case. And frequently locked singleton records, things like some kind of master preferences setting that every single operation has to write. That basically causes the application to single file its way through the database. Very bad. And very long running transactions. The absolute worst possible case of this are applications. These tend to be applications that were ported from older versions, older databases, where the user opens a record, gets it onto their screen, and is holding a transaction open in the database in order to support the cancel operation. That is really bad. There's lots of things in Postgres do not wait for transactions to be closed. You'll build up locks. It'll be very, very bad for performance. The way to use transactions in Postgres is get in, do your business, commit, get out. You can change as much as you want. You know, PG restore runs basically inside of a single transaction, so you can restore an entire database in a single transaction. But don't wait for anything asynchronous inside a transaction, a web operation, user input, that sort of thing. Part 2. Postgres has a built-in operation called copy. It's specifically designed for bulk loading. Use that. Don't use inserts. It's much, much lower overhead to use copy. This is a very common thing that happens as systems evolve, which is you'll have a database that's accepting transactions like, you know, web orders, whatever. Lots of little transactions. Lots of little stuff goes in. And then you need to do these big analysis queries. And they come in and run at the same time, and the whole system falls apart. The website starts responding. Horrible things happen. Generally, transaction and data warehouse, those kinds of data analysis workloads do not mix in the same database. Postgres has built-in streaming replication. A very nice thing to do is move all that data reduction load onto your secondary. It's read-only, but so are your queries. So very nice fit. So this is something, especially developers who are using ORMs of various kinds. I love ORMs, just to be clear. I'm not the typical database ORM hater. But they do have some pathologies. One of them is gigantic in clauses, which is very frequently you'll see in the application code, go and get me a bunch of primary keys, and now go find everything get all the records with those primary keys. That's called a join. Do it as a join, not as an in clause. The problem is it becomes very easy to write that in like Python, like in Django's ORM. It looks so innocent, just sitting there. It's just 2 lines of code. What could possibly go wrong? I actually had one client who ran themselves out of disk space because the queries that they were logging were so gigantic. They had like 400,000 items in the in clause. So be careful about that. If you're doing unanchored text queries like this, find everything with the word this in it. What you want is full text search because there is no standard index in the world that will optimize that query. It'll have to grovel through the entire table. And of course, groveling through the entire table takes a long time. Let me explain this one. This is kind of related to this. Where you frequently see this is in applications. They will have a loop that says, get me this record, process it, hand it back. Get me this record, process it, hand it back. Once in a million years, you actually have to do that. But what you really want to do is an update statement, is send a single update to the database and let it do that work. So if you get it, you see these pathologies where you're doing small volume a small query and processing in the application, everyone has to come back and forth over the wire, back and forth to the database. Use that. Okay. Indexing is a fun topic. One of the trick questions is, so what's required in the SQL spec for a database to implement indexing? And the answer is, the SQL spec does not, in fact, talk about indexing at all. It is not present in the SQL spec. Indexing is an implementation detail left to the database. So people love indexes because there's this idea of like the index is the go faster button on the front of the database. Is like, oh, well, and I will literally have people, clients call and say, well, could you add some indexes? And the answer is, well, sure, I can add anything you want, and that will probably hurt your database more than it will help it. Indexes should be added, but only judiciously. So what's a good index? When should you add an index? A good index has these properties. It has high selectivity on commonly performed queries. High selectivity means when you do the query, you get back a small number of rows compared to the overall size of the table. So if you have a 1,000,000 row table and you do a query and get back 4 rows, that's very selective. That's good. If you do a query and get back 750,000 rows, that's very unselective. And an index, in fact, if you force it to use the index in that environment, you will actually get worse performance than just scanning the table and throwing away the quarter of the rows it didn't want. Also, the other part is that these are on commonly performed queries. If you run this query once a week, no matter how selective it is, it had to spend the entire week maintaining that index, and index maintenance is not cheap. Every time you insert it into that table, it had to maintain the index. So it's often better to leave an index off if it's only going to accelerate 1 query a week. If it's going to accelerate 1 query a second, then that's actually, of course, it's extremely useful. The other thing is sometimes you have to have an index, like enforcing constraint, like a uniqueness constraint in the database, most commonly for a primary key. You have to have an index, so you might as well live with that. So what's a bad index, given those 2 criteria? Every other index is a bad index. If it does not meet one of those 2 criteria, don't add the index, because indexes can be quite expensive. It is not uncommon to see indexes take up more space on disk than the primary table, and it is not uncommon to see more time being spent maintaining the index on an insert than it's spent actually writing the row itself. So if it's non-selective, if it's not used very often, or if it's very expensive to maintain. An expensive to maintain query would be one, for example, that has a function call associated with it. Postgres lets you index on the results of functions. That can be super powerful if you use that query based on that function a lot. But if you only use it once in a while, it may not be worth it, because every single insert pays the expense of that index. Another note is if you have a multi-column index, only the first column can be used separately. So if you index on A and B, and you query on B, that index won't help you. So the moral of the story here is don't go just randomly creating indexes on a hunch. That's what I do for a living. To find out, there are 2 built-in tables, views, inside of Postgres. If you go and look at pgstat user tables, it shows you how many times a sequential scan has been done on that table since the statistics were reset. If you go and look at stat user indexes, it shows how many times that index has been used. You can compare those. If you see a lot of sequential scans, it's a good idea to start investigating, well, what are the queries that are causing those? And maybe an index could be helpful. If you see an index that's hardly ever being used and it's not used to enforce a constraint, then it might be a good idea to see if you really need that index. Okay, so don't do any of those things and you'll be in a much better shape. Ongoing maintenance. So we'll talk a little bit about monitoring, backups, disaster recovery, schema migrations. Yeah. Monitoring. Always monitor. Nearly every emergency situation I'm called in on said something was screaming in pain before the database fell over. Disk space, errors on the disk, something. Once in a while, just a meteorite hits, but most of the time, just a little bit of monitoring goes a long way. At least monitor disk space and system load. It's really embarrassing to run out of disk space. It's hard to explain why that just happened. It's also very handy to monitor memory and I/O utilization, especially I/O utilization, because usually the first place a database server starts running out of steam is on I/O, not on memory. Postgres is pretty conservative about its memory use. That's rarely the problem. Usually this one. So monitor that. Do it in 1-minute bins. Generally, the default could be between 5 and 15 minutes. That's way too coarse a setting. If you're using Nagios, which is sort of the most common way to monitor systems, or something that can use Nagios plugins, if you go to bucardo.org, there's a check_postgres.pl that will monitor every imaginable thing, including things I can never imagine why you would monitor about Postgres. It's very, very useful. So let's talk about backups. The basic way you back up a server is pgdump. It comes in the package, comes straight out of the box. Is very low impact on the database being backed up. Note that there's this misconception, I think basically because of other databases, the way they do backup. A Postgres database that's being dumped, you can still write to it. It's full operation. It's not building up changes in memory or doing any of that stuff. It's a normal, fully operating database. There's I/O load, of course, because it's having to shove things off, but everything works just fine. There are some small exceptions, like if you try and change the schema, it may lock until the database is done, but normal operations, it's going just fine. It makes a copy of the database. It's a logical copy, not a physical, disk copy. It makes a copy as of the moment pgdump started, so it's logically consistent no matter what happens to the database after pgdump starts. But the problem is, it makes a copy of the database. So when you have a 1 terabyte database, copying an entire 1 terabyte database can get to be a bit tedious. So it does, in the tens of gigabytes, pgdump starts becoming impractical as a primary backup solution. Thus, we have streaming replication as of Postgres 9. It's the best solution for large databases. If you have a big database, a primary and a secondary, the secondary provides your backup, it's great. Even if you don't use it for anything else, just as a backup solution, it's the right way to go. It's really easy to set up. I am sure that anyone in this room could read the docs and set it up. We're perfectly happy to take your money to do it, but really, that's not the efficient use of anyone's time. It maintains an exact logical copy. So everything you do on the primary happens on the secondary. The downside is, first of all, if you're running a VM, make sure you really is on a different host. Specifically, for example, on Amazon, Amazon won't tell you anything, but they appear to have client affinity for virtual machines. So if you create 2 instances on Amazon in a row, they will probably be on the same machine, which of course kind of defeats the purpose of using this as a backup in the case of hardware failure. One of the downside here is it doesn't guard against application level failure. So if your application wakes up and runs wild and starts crunching data, that crunch data will be pushed across the secondary as fast as the little replication connection can carry it. If you drop a table by accident, it drops on the secondary. It also is all or nothing. So you can't just say back up these tables or back up this database or anything like that. It's the entire physical cluster, which 9 times out of 10 is exactly what you want. But if you need a more sophisticated solution, that's, it may not be the perfect answer. You can use a replica for read-only queries, which is really, really, really nice for doing those big warehousing type queries, so you don't load down the primary that's actually receiving the write operations. Occasionally you'll do this and you'll start getting these messages about query cancellation, and it always really hurts when I go into a client and they say, well, we tried streaming replication and we got these query cancellations, so we spent the last year of our lives fighting with Sloaney to get it to work instead. And I have to tell them, there's 2 parameters you can change in Postgres to fix that query cancellation problem, and you could have gotten the last year of your life back and not have to deal with Sloaney. In fact, you can usually just bump up this one. It's not completely without consequences, but 9 times out of 10, that will fix the problem. And I can explain offline if you want to know what's going on there. But if you get these query cancellation messages, that's the fix. You can also pgdump a streaming replica. So if you need to do a secondary backup to guard against application failures or things like that, you can dump your replica rather than the primary. So remember, it's all or nothing. If you need partial replication of some kind, you need trigger-based replication. Sloaney and Bucardo, and there's a talk specifically about Sloaney versus Bucardo later, are the way to go. These are tedious to set up and fiddly and need constant maintenance. So just be warned, you are going to be on the treadmill with these guys. One of the unfortunate things is they all have failure modes that do not immediately cause lights to flash and bells to ring. So you do have to monitor them carefully. Yeah.
Before we move on, I'm just curious, if you were using streaming to do something like data warehousing,
Mm-hmm.
can you add indexes to the replicated copy that are
No.
on?
No. When read-only means read-only. So no indexes, no temporary tables, none of that stuff.
Did you have to build like a third database in SiteMind or?
Yeah, you know what you can do is as a quick interjection, what you can do is set up the streaming, break it, and then re-image the secondary. Of course, if it's a like 4 terabyte server you're dealing with, that can be kind of painful. In those cases, what clients tend to do is they use trigger-based replication, so that, because the secondary can be written in that case. It's unfortunate, but you know, if you're throwing around a multiple terabyte database, you probably are willing to sign up for slightly more sophisticated things. No, it's not a perfect solution in those regards. Because things like doing temp tables for like pivots and things like that are really common. So there's one more way of doing backups that frequently we install alongside of streaming replication. This is called wall archiving. It's also sometimes you'll see it called wall shipping or something like that. This was actually pre-9 the way you did large database backups before streaming replication appeared on the scene. You can do a series of base backups and wall segments on a remote server. Effectively, you're taking a disk-based snapshot of it and then a list of all the wall segments that are the changes that have happened to date to that. The nice part about this is you can replay that to a point in time, which is really handy. So if you know something really horrible happened at 10:30 last night, you can replay the database to 10:29 and bring it up in that state. And that's really nice. This is why, for disaster recovery, this can be really, really very handy. It takes much longer to bring up one of these than it takes to promote a secondary to being a primary. But if this is the only way you can get your data back, that could be extremely useful. It's well worth the security. Frequently, this remote server, is set up in a different data center. I live in San Francisco, so data center destruction is not a completely academic idea. So you know, since I'm in San Francisco, sometimes I'll set this up in like Fresno, which probably will not get a huge earthquake at the same time we will. And you can use it at the same time you're using streaming replication. So okay, let's talk a little bit about quick diagnosis of database problems. Obviously, this is an endlessly fascinating topic that you can go on to for years, but just some basics. Learn how to use PSQL. It's the command line interface to Postgres. It looks really intimidating. It's friendly. It likes you, really. Because a lot of the first level diagnosis is frequently, if I'm on the phone with somebody, is, okay, log into PSQL. So just kind of know how to do that. The things you want to look at are the first level, especially if things are seem to be backing up and you have lots of connections open. There's two views, PG stat activity and PG locks. PG stat activity shows all the connections that are open to the database and what they're doing at this precise moment. What query they're running, if they're idle in transaction, which we'll talk about later. And there's a flag in there that says waiting. And if waiting is true, that means it's waiting for a lock. You can then go to PG locks and see who's waiting on the lock. If you cycle back and forth between these, you can find out who holds the lock those guys are waiting on. There's a process ID that is used to identify the connection in both places. And you just kind of bounce back and forth between them. You don't even have to come up with a really fancy join or anything. You just show one, show the other, and then kind of like scroll up and down and look at them. This will get you 9/10 of the way to figuring out what's going on if it's a lock-related issue. So that's the quick diagnosis on lock issues. So here are some things that can jump up and bite you when you're least expecting it, that you should know about. Database encoding. Back in the bad old days, most packages installed with bad encodings for some reason. Now that problem has largely been fixed. The encoding is what character set the Postgres thinks the database is by default. It's fixed when the database is created. This slide is slightly out of date. Now, generally everything's created as UTF-8, which is what you want. There was a time that packages, especially the primary packages for distros created things as clocale and SQL ASCII. And what would happen is people would wake up 4 years and realize they had a SQL ASCII database and needed to convert that to a UTF-8 database, and that's kind of expensive and painful. There are circumstances in which clocale does make sense because string operations are much faster in clocale and SQL ASCII than they are using UTF-8 for things like sorts and things like that, but only do that if you know for sure that's going to be a big problem for you. Otherwise, just accept the default as UTF-8. Occasionally you'll go out on the internet and see people giving advice on how to convert one to the other by patching system catalogs. Please don't do that. Those people are not your friends. So we're going to talk about database migrations. So who's done things like this? You have this big database, and you want to add a column to it, and there's a large table that has a few million rows on it, and so you go in and log in and say alter table, or use your favorite migration tool. Like if you're a Django person, use South, and you add this column. And you push it out to production, and then Postgres promptly takes an exclusive lock on that table, and the whole system falls over. So I've heard about this happening. Not that I've ever done this. This is a problem. If you add a column to a table, and that column is not null and has a default, Postgres will rewrite the entire table while holding an exclusive lock on that table. Obviously, this can take a long time. And if it's a big table, it's probably an important table, which means the whole system is effectively blocked while this table is being locked. This is very bad. So you don't want to, so here's how you handle this problem. You create columns as nullable without a default. You then add the constraint later once you've populated that field. This takes a lock, but it takes a faster lock because it only takes a lock long enough to modify the table structure, not to rewrite the entire table. Also, 9.2 has a not checked feature for the constraint, which means you can add the not null as not checked, and it won't do the whole rewrite because it'll allow null values to appear in it. Of course, your application has to realize that null values could come back from this column that it thought was not null. Now, this isn't going to be super fast. It still has to rewrite the entire table, but it can rewrite the entire table while the system is still in production. And that could be significantly less painful than having to lock the entire table and have the whole system go down. The other option is you can create a new table and copy the old values into it. Of course, then you have to figure out what to do about updates to that table while that copy was in operation. Occasionally, so now that you're smart and you go in and look at PGSQL and you look at PG stat activity, occasionally you see you'll see something that says idle in transaction. You'll see sometimes things that just say idle, close bracket, close brace. And those are fine. Those mean exactly what they sound like. They're a connection that's open, but it's not doing anything at this precise moment. But then you'll see these ones say idle in transaction. What does this mean? This means someone's begun a transaction, someone being a program usually, and done some stuff, but they haven't committed, but they're not doing anything right now. It's a transaction that's left open. These are bad. You do not want to see these. Occasionally, once in a while, you'll see it transiently because you'll just happen to hit the moment between statements. But if you see one persist, and one thing that PG stat activity has in it is how when the backend started, which is there'll be a backend start time, which is when that connection opened. And you can see the last query time. So if these are like starting to drift into the past, these are really bad. You should never see this state in a Postgres database because it potentially means something could be holding locks on tables or on tuples and not releasing them. So kill them, get rid of them. Find out what's causing them and get rid of them. Vacuum freeze. Vacuum freeze is like this evil thing because it's so surprising. Without going into details, once in a while Postgres needs to scan and sometimes write every table. It just needs to. Just accept this. And once in a long while means like it depends entirely on how busy your database is, but 8 months, 24 months, sometime in that range. It really depends on how many transactions are going on in the system. And this can be really surprising because everybody runs AutoVacuum, or most people should. And sometimes Postgres out of nowhere will just wake up and start rewriting a table, and you think, what the heck is going on with that? It can be a really big surprise, especially on a busy system. So the solution to this is, once every few months, pick a very slack time and issue a vacuum freeze to your database. Basically, you can't keep it from happening, but you can pick the time that it happens. One of my favorite things to do is on, if you're running on a system that has basically sort of Western, mostly Western, US and Western European clients, sort of Romance language speaking clients, you, at 5 p.m. on Christmas Eve, fire off that. Of course, if you're running a system that does not have that characteristic, this may not be a slack time for you. But the idea is you're just staying ahead of this. Let's talk a little bit about pooling. Remember how I said don't just bump up max connections because you feel like it? If you feel like you need more than 200 connections open to your database at the same time, consider using pooling software. If you need more than 500 connections, you definitely need pooling software. Basically, there are two choices for pooling software right now out there in the wild. The first one is PG Bouncer. It is cheap and cheerful. It's a really neat little program. It was written by Skype for their Postgres installs. It's very reliable. It's very mature. Basically, all it does is multiplex a lot of client-side connections down to a small number of server-side connections. That's all it does. It does it really well. It does not have failover. It does not have load balancing. Those are problems left to the reader in the case of PG Bouncer. Don't automatically rule it out because you think you might at some point need that stuff. There are ways to add it on top of PG Bouncer, and PG Bouncer is a good first step for this. And really, this is another thing that you don't need to pay us to set up. It's very straightforward, virtually self-documenting. Not every application can take advantage of it. The more sophisticated your use of the database is, at the point you're starting to use stored procedure, or not so much stored procedures, but prepared statements and complicated session contexts and things like that, at some point you won't get full benefit out of any pooling software. But for most, especially web-style applications, almost always, PG Bouncer will take care of it. Your other option is PG Pool 2. PG Pool 2 has all the bells and whistles. It never saw a feature it didn't like. It does failover between replication pairs. It does load balancing. It's replication aware. So if it sees the master go down, it can run a script to promote the secondary and move traffic over to the secondary. It does some query analysis. It will look at the queries as they're going by, and if it thinks it's a read query, it'll send it to the primary. If it thinks it's a write query, or a write query, it'll send it to the primary. If it's a read query, it can send it to the secondary. So it can distribute those for you. Makes thousands of Julian fries. I mean, it's like full of features. However, it is complicated to set up and quite fiddly, especially if you're running it on a high availability solution. So be aware that this is going to be a little bit of a project to set up, especially to get all the details right once you're doing primary and secondary. Okay, a little bit about some additional tools. For replication, our friends at Second Quadrant have put out this repmanager.org are some very nice tools for managing replication. If you're on Amazon, all one of you, Wally from Heroku, also, it's purely coincidence these are sponsors, by the way. The slides have been around for a while. These are very nice for doing wall-based backups using Amazon snapshotting capabilities. PG Badger is a relatively new log analysis tool. It has, at this point, I think, replaced PG Fuin, which was the old log analysis tool. A Fuin is a stoat, or a kind of weasel. So I guess we're continuing the small mammal theme here. I think it's because badgers root around in logs. I'm not sure why otherwise they call it that. It's written in Perl. It's a very nice tool. It's being actively maintained. PG Bouncer I mentioned already. And there's my blog. there's my company's blog. And time for questions. Any I didn't hit? Everyone's still asleep? Sir?
We're using Oracle Shop right now.
Mm-hmm.
We have a number of applications doing into Postgres and Mongo. And so there's some discussion about why are you using Mongo? Why don't you just use Postgres for your key value store?
That's an excellent question. I would ask the same question.
Okay.
Yeah, why not just use Postgres? It's the, Postgres especially now has JSON types as of 9.2 and all sorts of cool stuff. And when you compare apples to apples as such as you can with Mongo and Postgres, I think you discover that Postgres' performance is pretty much there. And so I'm very comfortable using just Postgres for that stuff. I mean, I'm a Postgres guy, of course, but still. I mean, the Mongo versus everything else versus Postgres debate is a fairly deep one. But if you, I think a lot, I will say, and acknowledging the selection bias, because of course we're a Postgres shop, we do see this pattern of companies falling silent. And in 6 months they come back to us and say, you know, we tried moving everything to Mongo, kind of didn't work out, so we're back on Postgres, can you help us? So, yeah. Of course, I'm also a Postgres guy at a Postgres conference, so there's an intrinsic bias there. Sir, in front, next person up, you had a question.
My only question is that why aren't more of these values, I guess, default? I mean, especially when you talk to
There's a lot of history there. The idea is a lot of them are set to extremely conservative values so that if you just accept all the defaults and fire up, you are guaranteed Postgres will start on any hardware, including 1992 era laptops. You know, it's so there's a lot of history there. They are slowly moving. The good news is the number of those configuration parameters are going down, and a lot of them are being set automatically now. So, you know, Postgres has been around for a while, so there is some kind of history there. Anything else? Yes, they'll be on the. There's a version of them there now, in fact, from DjangoCon, but these particular slides will be uploaded later today. Yeah, on thebuild.com. Anything else? Looks like we're pretty much out of time. Thank you.